Oh, it is. All right. Okay, so let's share our screen here. And it says here, so we got the data, represent, this is problem 11 on page 460. 4 gigabyte flash drives, whatever, at online retailers. It's normally distributed. S equals $2.343.
Username.
Yeah. Construct a 95% confidence interval. Do we need the raw data?
No, we just need to know how many up there are.
Yeah, so there's 2, 4, 6, 8, 10. So your n equals 10. Okay? A 95% confidence. We could do 96 if you want. 95% confidence interval. So how do we do that? Okay, so the formula, isn't the formula n minus 1 s squared divided by either, I'm just going to put chi squared on the left or the right, right? Okay. So we've already got our 10, our n is, n equals 10. Move this over here. Okay, n equals 10. We've got my s equals 2.343. Now I need my chi squared on the left, and I need my chi squared on the right. Apparently I turned that into an email address or something. Okay, so how do we find those? How do we find those with Excel? That was your question, right?
Yeah.
Okay. So we're also probably going to need my degrees of freedom. What's my degrees of freedom? 9 degrees of freedom. Okay. So how do I find this with Excel? Did you call it chi? Are you just giving me a hard time? Okay, chi. How do we find chi? CHI, there you go. Now, which one is it? Is it the dist or is it the inverse? Well, we got chi dist on the right side, and we got chi inverse on the right side. Which one is it? Inverse. Okay, so we're doing. So I'm going to pick this one here because if it doesn't specify, it's the left side. Okay. So what's my probability on the left? What is it? 0.05. See, this one you always just do the tails to make it makes it nice. It's just the tails. No. Oh, actually, yeah, it is 0.025. You're right. Because yeah, we want 2.5% on each side. Because I forgot to draw my picture. Screwed me up. Okay. Draw your picture. Okay. And the degrees of freedom is 9. So you can look at your chart and make sure you get that right if you want. But yeah, it should be very close to 2.7. Chi squared on the right is chi square inverse on a right-tailed probability is 0.025. Degrees of freedom, still 9. And I got 19.02. Okay. All right, so I'm going to do my lower, do my upper. My lower is 9 times S squared divided by no, it's going to be the 19. Remember, you want the big number on they're backwards. But either way, you pick the 2. Who cares? Just switch it around when you get done. When you're done, okay?
That will be, but I put it in the right position.
Yeah. Just move it around after the fact. That's fine. Okay. And the same thing. 9 times S squared divided by the small number this time, because now it's going to be the big number. Okay. Now, what did it ask for? Did it ask for the variance, or did it ask for the standard deviation? What did I find? I found the variance, right? So the standard deviation is square root of those. Just do that. Okay. Now, by the way, just as we're looking here, is 2.343 in my interval? Not. That's kind of a clue that you may have done something wrong, but it is in my interval here. Do you see that? Okay. So pay attention whether it says variance or standard deviation. I could ask either one. Okay. All right. What else you got?
So on this chi-square stuff, do you expect us to graph any of it?
Well, on the computer stuff, I'm not going to see your scratch paper. So, no. But let me mention this. I used to say, oh, just pull up paint. No, don't do that, because the testing center told me that apparently you can cheat somehow with paint. I don't know how you do that. I do not know how. But if you pull up paint during the test, they will flag you for cheating, and they'll be like, Mr. Bennett, he pulled up paint. That's terrible. And I'll be like, who cares? Whatever. Anyway, but I don't want that email. Okay. So, did I tell you guys one time I did a test about the lottery, and I forgot to put data on there? And so one of my students did a Google search for the lottery, and they were like, oh, and I was like, oh, I'm sorry. Anyway, but they have caught guys cheating. They caught somebody last semester cheating. So they watch you guys like a hawk. I will also tell you this. Hope this doesn't happen to you. I felt bad for the poor student that it did. Apparently, they can reboot your computer remotely, and the person was almost done, and they rebooted his test. He lost his test, his whole test. I was like, and he's like, I gotta go to work. So anyway, so I let him take it again, but that sucked. Yeah. So anyway, they do watch you, so don't cheat or you get a 0. So yes.
So with the confidence intervals, we have pretty much 4 equations for like 4 different scenarios. With the population proportion or like binomial data, we're supposed to be using the z-score one to give us the beginning. What's the difference between that one and the population standard deviation? Is it if we know it, we use the t-distribution, if not the z distribution? Is it the same equation?
I think it was just the opposite of what you said. If you know the population standard deviation, you use the
population,
the z or the t. So they give you the population standard deviation in the problem. You use the z or the t. Use the z. If you don't know it, you use the t.
but otherwise it's the same equation.
They're very similar equations. You're talking about for the confidence interval, right?
Then how can you tell whether to use the chi or the z?
Okay. So the question is really, how do you know whether to use the chi, the z, or the t? Okay. So here's how you know. Let's see. Here, I'll just write this on the board. I'll stop sharing. Okay. To be honest, well, I'll just give it to you now. next week, I'm gonna give you like this whole big outline. You guys are gonna love it because we're gonna start hitting distributions and hypothesis tests hard. And the nice thing about it is the confidence intervals follow the same requirements as the hypothesis test, which we're gonna learn next week. Hypothesis test is where this class gets harder. Okay, just warning you. So that's next week. It's what you have to look forward to. But, and in fact, I'm going to ask you, well, some people memorize this like 2-page. I had somebody that actually memorized my 2-page outline, and I was pretty impressed that they did that. But if you want to do that, it works. So you're going to use the Z distribution if it's a parameter like P or P hat. I'm going to put P hat there. Or if you know the population standard deviation sigma. Okay? And these are good general rules. So that's the Z distribution. You're going to use the T distribution if you don't know population standard deviation sigma. Okay, so I'll emphasize the don't know. Okay, and it's also for a mean. This one can be for a proportion, or it can be for a mean. Okay, you're going to use the chi-square distribution. Okay, there's going to be more things, but for this test, all you need to know is it's a confidence interval for a population standard deviation or variance sigma. Okay, so in these cases, I'm doing a mean for the chi-squared. I'm doing a confidence interval for the standard deviation. Now we're going to add to that list actually next week, but for this test, this is all you need to know. Okay, and I think it's on Tuesday where I'm going to give you this really big long outline that is going to be very, very useful. Not in the book, but it's going to be awesome. You'll love it. Okay, and just FYI, just as a preview, we're going to do another distribution called the F distribution, and you'll be like, F that, right? No, just kidding. Okay, so that's coming. You don't need to know about that for this test, though. Okay. Yes.
What's the difference between a QQ plot and a normal probability?
Difference between a QQ plot and a normal probability plot? There is no difference. It's the same thing. Okay?
I've just been studying, and we couldn't figure out how we did number 1 round on this quiz.
Number 1 wrong on this quiz. I don't know why I recorded this, but okay. Yeah, so I'm going to try to keep this semi-vague, but hopefully good enough to answer it. The picture there is the sampling distribution, not the population. If it was the population, your answer would have been correct. But since it's the sampling distribution, you do it backwards. Does that make sense?
Okay.
Okay. Any other questions?
We need to use as much, as many as we can excel.
Yeah.
Keep like that.
Yeah.
There.
So you will have the tables. You can kind of use that as a backup to kind of check your answer, but yeah, please use the Excel functions as much as possible. Yes.
On this test, will it only give us S like that?
They could. That's why it was kind of weird because they gave you data on that problem, and I was like, you could have found it yourself. So it could go either way. Typically, I'd have probably given you the data and you just found it yourself, but either way. Romero,
For finding the standard deviation,
I can't hear you.
for finding the standard deviation, if you've given us the set of numbers, is it for population and percent.
Okay, so the question is, for those on video, if I give you a set of numbers, is it population or is it the sample? How would you guys answer that question? It's usually a sample, unless it says it's population. It could be a population. But yeah,
So unless
I
you
would
specify-
say more than 75% of the time it's a sample.
So unless you specify, it's going to sample.
It would specify that it was a population, yeah, if it's a population. So,
How many questions?
you know, I actually give for the computer port, there's 7, but they're short. So I think most of them are just A/B parts. I think there's one that's a little bit more than that, but yeah, there's 7. So there's more questions, but they're shorter. Okay, Samantha?
What will we have to graph anything?
We have to graph anything.
QQ plot, right?
QQ plot would be the most likely because that's on this test. You'll probably want to draw a picture on your scratch paper, but you don't have to turn that in. I could ask you maybe a histogram, but I don't think so. So be ready in case. Yeah, in case I'm wrong.
Yeah, could we go for the QQ file like you have to buy I minus
QQ plot.
0.37?
Sure. You guys remember, that's the one formula you need to remember in case I forget to put it on the test, okay? You remember the formula? The formula is S sub I, excuse me, equals I minus 0.375 over N plus 0.25. So that's the only formula you should have to memorize because I often forget to give that to you. Okay? If it's in class, I'll write it on the board. But on the computer test, if I forgot to give it to you, just memorize it. That's the only formula you really need to memorize in this class. Okay? Yes.
We're 7 through 9, chapter 7 through 9 is test, right?
Right. Chapter 7 through 9. Okay, so let's see. You want to just pick a problem? I can't pick a data. Unless you want to do just a bunch of random numbers, we can see if the random numbers are normally distributed. Sometimes they are. It's weird. Do you want to do that? Do you want me to just pick some random numbers?
Sure.
They probably should not be distributed. Okay, so we're going to try this. I've never done this before. Okay. So these are random numbers. They may or may not be distributed or normally distributed. I don't know. So rand between, what do you want it to be? Can we think of 2 numbers?
0 to 100.
Well, that's wimpy, 0 to 100. Okay. And how many should we do? We'll do 20 of them or whatever. Okay, these are the numbers we came up with. Okay. So, how do we do this?
First, you have to copy the numbers.
Yeah, I already did that. Copy, paste special. Okay? Paste special 1, 2, 3, so they don't keep changing. Mine aren't changing. Okay? Paste special the 1, 2, 3. Okay? So, or you can just type my numbers if you want them to match mine. Now what?
Want to find the average?
Nope. Don't care about the average on this.
Because when I do it,
No. Normally you'd find the mean and standard deviation. I don't care about it on this.
You find the index numbers?
Nope, you're missing a step before you assign the index numbers. Sort them. Most common mistake is people forget to sort them, okay? So you click on data, you sort A to Z, okay? So don't forget to sort. That's the most common mistake, okay? Now we're gonna do our index numbers. 1, 2, 3. I don't want to count, so I just do the first 3 and then double click. Boom. So I've got 19, all 19 numbers, okay? Now what? Into the equation, so I need to find my S sub I. So this is I minus 0.375, you got my decimal, divided by 19.25, right? Okay,
No,
what'd you say? 19.25, or 19 plus 0.25, you could do that, that's fine. Okay, now what? What'd you say? Find the z-score. How do I do that?
Equals norm.
It's norm S what? Norm S this or inverse? Inverse. And don't use the one with the periods, it's a little harder to use. Actually, I don't think it matters on this one, but I always like the one without the periods, okay? Norm S inverse of that. Okay, now what? What? The F sub I. Okay, now what?
Now you highlight your data and use it.
Highlight your first column, your data, and you hold your control key down, do your last column, your z-score, and then insert, which one? The scatter plot. What do you think? You want me to do the z-score again? It's norm S inverse. Norm S inverse of your F sub I column. So what do you think? Does this data look normally distributed to you? No, it does not. No, because why?
Two curves.
Definitely got some big curves here. From here to here, it looks pretty good. But we've got a big curve, so we got a big curve on both ends. Okay? Would you expect random numbers to be normally distributed? I mean, if you were to draw this, 19 is kind of a small sample size, right? If you were to draw this and you knew it was a uniform distribution, what would it look like? It look like a rectangle, right? Now, just for fun, time's up, but if you want to stay for 1 minute, we can draw a histogram just to verify and see, does it look like that? Okay? So 1 minute, this is for bonus time, histogram. I know you guys love histograms. Let's go 0 to 19, 20 to 39, 40 to 59, 60 to 79, 80 to 99. And then I got my count. So we're going to 19, so that's 6. Now we're going to 20s and 30s. Oh wow, that's only 2. That doesn't look normal. 40 to 59. Oh wow, that's only 2. This doesn't even look like random. 60 to 79. That's 3. And 80 to 99. That's also 6. Wow. That doesn't even look like a random distribution. Insert, scatter, or not scatter. Thingamajig. They're random numbers. It's a small sample. What would you say? Bimodal. Okay. Should look like this, but small sample size. Okay. All right. See you all tomorrow. Good luck on the test.
Is there different Excel